It's another math day here with teacher Jenny. Join me for another topic. And this time we're talking about logarithmic expression, how to expand it, and how to write it into single logarithm. So let's start with revisiting our rules or laws of logarithm. So we have actually three rules or laws of logarithm that we need to consider. We have the product rule, in which once you have a logarithmic expression in which this number here is expressed as the product or in terms of multiplication, then we can expand that one into log of the first factor, which is x, to the base of b, plus log of y, which is the second factor, to the base of b. Next, we have quotient rule, in which once we have a logarithmic expression with this number here as expressed into a fraction, then we can expand that one using subtraction. So we have here log of the numerator to the base of b minus log of the denominator to the base of b. And then lastly, we have the power rule. Power rule, we have log of x to the power of n to the base of b, wherein your number here is expressed in terms of an exponent form. Then we can just do the power rule. So we can simply put down our exponent beside your log. That would serve as being multiplied to the entire logarithm. So we have here n times logarithmic, log of x to the base of b. So let's go for an example in expanding logarithmic expression using the rules or laws of logarithm. So let's start with the first one. So we have expand log of 7x to the base of 3. 7x here is expressed in terms of factors, so we can simply expand this one as log of 7 to the base of 3. Since this is product, we'll add that one with the log of the second factor, which is x, to the base of 3. So that is now your expansion. So let's go to the second one. Expand log of 2 over 3 to the base of 3. So notice this is in terms of fraction. So we can expand that one as log of the numerator, which is 2 to the base of 3, minus, because this is quotient, minus log of 3 to the base of 3. So that is now the expansion. So here, because we're dealing with expansion, no need for that one to be evaluated. So let's move on to the next one. So expand log of x squared to the base of 2. This is in terms of an exponent form, so we just use power rule, in which we are to bring down our exponent, which is 2, and then copy our log of x without that exponent, and then to the base of 2. So that is now the expansion. So here we have log of cube root of x to the base of 5. In writing the expansion, we must know that when you say radical numbers, this could be written in the format of a number with a fractional exponent. Now notice that this is with an index which is 3. This is a radicand. The radicand here has only 1 as an exponent, so you can write this one in terms of a number with fractional exponent as log of x with a fractional exponent. Now on the fractional exponent, your numerator will be the exponent inside the radicand. So we have 1 here, so we will write 1. And then the denominator will be the index. The index here is 3, so we just write it 3. And then to the base of 5. So since this manifests a power, so we will be using a power rule. So bring down 1/3, and then we copy log of x without that exponent to the base of 5. Next one, we have log of 2x cubed to the base, 2x cubed over y to the base of 5. So how to expand this one? We are going to look at this one in general format. This is in the format of a fraction, so we just go for the quotient rule. So log of 2x cubed to the base 5 minus log of y to the base 5. Because again, this is quotient, so we have to subtract. Next one, you have to make sure that each of the logarithmic terms, are without product, quotient, and power. So if each of your exponential form doesn't have those three, then that means to say that's the final answer. But if it contains one or more than those rules, then you have to simply expand that further. So upon seeing first term, you have there 2 times x cubed. We have a power and a product. So we will be following first the product, because again, your power here is only for the x term. You don't have a power on the 2. So that is why when we expand this, this is now log of 2 to the base of 5 plus the other factor, which is log of x cubed to the base of 5 minus log of y to the base of 5. Now, next one, the second term contains a power, so we have to expand. So log of 2 to the base of 5 plus, bring down the exponent, 3 log of x to the base 5 minus log of y to the base 5. So this is now your expansion. So we go for writing into single logarithmic expression. So write 2 log 3 into a single logarithm. So again, this is with under the power rule because you've got a number beside the logarithmic expression. So we just have to bring it up here as an exponent of the 3. So we have log of 3 to the power of 2. Again, we cannot see any base at all here. This is understood. This is base 10. This is common logarithm. So let's go for writing log of 10 to the base of 3 plus 2 log of x to the base of 3. Now, make sure that your expansion there has the same bases. Otherwise, if you don't have the same base, then that would simply mean you cannot write that into a single logarithm. So let's try this out. So we have log of 10 to the base of 3 plus 2 log of x to the base of 3. So this is a plus, so we go for the product. So we have log of 10 times. Notice this is with the number here, so we just have to bring it up on your x and multiply that to your 10 because this is a plus. So we have 10 times x squared to the base of 3, or we can simply write it as log of 10x squared to the base of 3. Next one, this is the last example. We have write 1/3 log of x minus log of x plus 1. So how do we write this into single logarithm? We just have to know that this is minus, so that means to say we are in a quotient. And this one is your exponent under power rule. So we have here log of x to the power of 1/3. We're dividing that one with our x plus 1. And our base is still 10. Next, we are to simplify your numerator. So this is now log of 1/3 here as a fractional exponent can be written into a radical number. So we have cube root of x over x plus 1. And that is now the final answer. So I hope you learned something from me today. And once again, this is your teacher Jenny saying good luck in every challenges in your life. Always remember that each problem that you are encountering will have some pattern to it, so that by next time, once you encounter similar problem, you know how to approach it and how to solve it. So once again, this is teacher Jenny. Please like and share my video. Don't forget to subscribe.